Hey, sixth grade friends, we're ready to talk about triangles and the area of triangles. In your book, in your student workbook, you'll find these pictures, and these are the big ideas. So when you have a triangle, you can actually choose any side of the triangle to be the base. And you can see this here with this first triangle. This is the same triangle 3 times. In the first one, the base is on the bottom, or what we think of as the bottom. On the second one, we have the base on a side that is not horizontal. And yet again, we have the base here on this outside. So you can choose whatever little side of the triangle that makes you the happiest to be the base. The thing about a base is, though, it always needs to be perpendicular to the height, which means you might have to extend the line to create your height, just like this one here. With this one, we didn't have to do that because we already had a line that was perpendicular or at a right angle to the triangle. So you might want to remember that the height is the length of a perpendicular segment from the base to the vertex opposite. The opposite vertex is that one that is not an endpoint of the base. So here, this would be the opposite vertex. Here, this is the opposite vertex. And here, this is the opposite vertex. And the reason it's the opposite vertex is because if we think of this as the base, it's directly opposite and not touching the base. So your opposite vertex will never ever touch the base of your triangle. So again, let's remind ourselves, you could draw a base anywhere you want on this triangle. And so in this case, we have it here. It's a horizontal base, but in order to create a height, we have to have that perpendicular line. And then we have to kind of make sure it goes to the opposite vertex. I'm going to take the time to write out the opposite vertex. So remember, if you're drawing a height that's outside of the shape, you're going to want to make sure it goes up to the opposite vertex. I hope you're hearing that in your dreams. Remember when we did our work now, so how we have here, this is our third step, we had originally worked with parallelograms. And for any base they share, the height is also shared. And we did some practice with that, where you could create a shared height. Now, when we were finding the area of this parallelogram, the area was base times height. And that equaled the area of any parallelogram. I'm not writing it out, but you know it's the area of any parallelogram. So when we look at this picture, what I notice is that half of a parallelogram is a triangle. And so the base and the height can help us find this area, because if I have the base and height of a parallelogram, and a triangle is always half of a parallelogram, then, drum roll please, we can use those base and heights to find any parallelogram, because it's going to be half of the base times a height, which is a area of a triangle. So here we have it. The formula for the area of a parallelogram is base times height. Triangle takes up half the area of the parallelogram with the same base and the same height. Nothing's changed. So the area of a triangle is 1/2 times the base times the height.